everyone. I am Prince Patel from Nanda High School, Ahmedabad, Gujarat. Today we are going to demonstrate our project Smart Parking System.
And I am Naiya Patel. We are from Team Tech. We all must have found it difficult to park our vehicle. So here is the solution. This project is a proof of concept of a smart parking system. It will allow people to easily find a parking space for their vehicles. It is a hardware-based project in which we have used IR sensor, servo motor, LCD display, Arduino Uno, e-bike, and for connecting them all, we have used the software VictorBlocks, which was very friendly to use. In this, when a person comes near the parking area, the LCD here shows how many parking spaces are there. And when the person enters the parking area, the LED module over here gives the direction to the person that where is the empty space for their vehicle. This way, the people will easily find a space for their vehicle. And we can also develop a software-based program in which this whole system can be developed using artificial intelligence and programming software.
So now let's see how it works. Here is e-bike car connected to mobile through Bluetooth.
So here the LCD shows that how many parking slots are left in the parking area. So now our car will enter the parking area. And our LED module shows the direction of the parking space. So now our second car will enter. So it shows a forward direction in the LED module. Now only 2 parking slots are left in the parking area, and our LCD also shows that only 2 parking slots are left. Now our third car will enter and it shows the direction of the parking area. As we can see, now only 1 parking slot is left. Now 1 car is leaving. So here a parking space is added. So let us see how we did the coding of the smart parking system. So as we know, we use the microcontroller Arduino Uno for our project. We have taken 2 variables, total slots, which we have set the value as 9 because we have 9 parking slots, and another left variable, which value we have set it to total slots, initial value, right? Now this is the initialized display. This is for the LED module for the directions which we have used. So it is the pin connection. Next we have used the LCD with I2C display. So we have put the hexadecimal code of the I2C, and then we have given the command to LCD to clear the display. Then we have set the column at row 1 and wrote smart parking, and at row 2 write total slots and set the value of total slot is 9, right? So it will display 9. Then there is a wait, we can say delay of 5 seconds. Then again it will clear the display of LCD, and then our loop starts. So first of all, on the LCD at row 1 it will display total slots 9, right? So then at the row 2 what it will display? Slots left. So how many parking slots are left? So it will display the value which is stored in the variable of left, right? Now our condition starts of if conditions, right? So here we have the digital sensor which is at the gate. So it is connected to pin 2 of Arduino Uno, right? So this is the gate sensor, IR sensor. So when the value of left is greater than 0, then only if it will perform the operations, right? So if the value of left is greater than 0, then it will set the value of left to left minus 1. So initially it was 9, so it will operate that 9 minus 1, so it will display 8, right? And then the next step, what it will do, it will move the servo to a 90-degree angle to open the gate for the car, right? And then we have a delay for the servo because the car takes some time to enter the parking area, right? So there is a delay for that. Now these IR sensors are the IR sensors connected to the parking slots. So we have divided our projects or our parking areas into 3 categories: left, right and front row, right? So here the IR sensor at pin number 6 and the IR sensor at pin number 7 are the sensors in the left row. Okay, so if the digital sensor at 6 is set to be low, right? It is set to be low, then the LED module which we are having, it will display this arrow, right? And if the digital sensor at 7 shows the low, then it will display this, right? Now next row we have of right row. So this is for the right. 11 and 12 are for the right. So again we have condition in there are 2 condition, if conditions. So this 2 it will display if it is a low at 11 or 12, anyone. Okay, so next row we have of a front row. So as there are less digital pins in Arduino Uno, so we have used analog pins. So these are the pins for front row. So we have till A3, and A3 after that we were lefting a pin, that is 13 pin. So these are 5 sensors in the front row. So there are 5 conditions in this rows. So these are the different arrows that are going to display if they show a low value, right? Now there is a else conditions, right? So after if there is no sensing at servo motor, right? If it shows low, then it will set the servo at 0-degree angle only. Now there is a second condition, second main conditions, it is of exit, right? So exit IR sensor is connected with digital pin 4. So if that exit gate sensor senses any object, then what operation it will perform, that if the value of left is less than 9 only, then only it will perform. Then it will set the value of left to left plus 1. So if there are already there is only 1 slot left, right, in the parking area. So when a car leaves, right, so it will set to 1 plus 1, 2. So now there are 2 parking slots left in our parking area, and it will set the servo to 90-degree angle to open the gate, and again there is a delay. And if it doesn't senses or the sensor has low value, then it will set the servo at 0-degree. Now if there are no parking slot left, if the value of left becomes 0, then what it will do, it will clear the display and it will write no space left.